Welcome to today's lecture called Structure, Programming is More Than Writing Code. So in this lecture you will not learn some new programming tool, but you will learn how to structure your programming such that you can apply these tools most efficiently. So you seldom just write some code, then it runs, you get the results, and then you never use the code again. In practice, there's firstly always errors in your code, there's so-called bugs, and you need to remove those first. And secondly, you need often to share your code with your colleagues or with your future self. And in both these cases, it's important to have structure in your code. Structure helps you find errors, and structure helps your colleagues and your future selves understand the code. In this lecture, we will talk about both macro and micro structure, and the idea is to prevent making errors in the first place, finding errors when they are there, and in general making your code interpretable for others, including your future self. So once you write some code, you often think this is very clear, I know what this code does, it's self-explanatory. In practice, it is not, and in the future you will not understand the code that you have written yourself. So when you have some code, you will need to clean it, you will need to document what the code is doing, and you will need to add comments to the code. This takes time, but it is an important aspect of good programming. Not just for sort of discovering and finding and removing errors, but also in terms of science, that in science we need to have replicability. We need to be able to replicate the stuff that has been done, and a transparent program makes this a lot easier. So this is very important things. But the first thing we will talk about is macro structure. So that is, how should you set up folders and files when you do a project. So it's generally a good idea to have one folder for each project where all the required files are in this folder. And then the end goal should always be to have one file to run it all. So that is, you can produce all the results that you need by just running this one file. That's the best thing, because then you don't need to sort of remember in which order you have to run files in these things. Then we will usually have some module files, some .py files where you define various functions and classes and so on. And there will be some notebook files that can call these functions and notebooks, these functions, classes and similar, and explain and present the results. In larger projects, you will also have subfolders where you will have data and figures and so on. That's not too important in this course. But to give you an example of how I often structure my code. So let's say I have some model and I have defined this in some class. So here I have defined it in the file model, my model class, and it's simply just the file called my model, and then there's this class, my model class, and that's sort of where I have defined everything. So sort of on the macro level, I know I can import this class. I know I can create an instance of the class. That's telling me that the setup is done. And I can see that I can solve the model, and I can simulate the model, and I can save the results. So this sort of gives me an understanding of what's happening sort of on the macro level. And now, of course, I will need to understand what is this actually doing. And all these things are in the Py files that you can also see in the left sidebar over here. But I can simply also just go to my model class, and I can press F12, and then it jumps to that file, and saying that now we can see what this is actually doing. So this has an init where it sets up the model. We have defined some x value, it sets the x value, and then it sort of sets that we haven't found the y value yet, and it prints the setup done. So remember that if I go back to the notebook, that was exactly what happened when I called this model class. It said now setup is done. And then this class has some various methods. We can see there's a solve method and a simulate method, and these are coming from these sub modules here. So we can go into them in a minute and see what they do. And finally, there's a directly stated method here, which is the save results, which we can see open a text file in the results folder and simply prints out the results. So we can see that file is here in the results xy.txt, which prints the results. But if we now go back to the my model file, then we can see that we have these two methods here, which is defined in the subfolders. Again, we can sort of just go to the line and press F12, and it opens up what that's doing. So here we are in the solve file, and we can see that it takes the x and multiply with the 2, and then we have our solution, and then it prints what x we have solved for. And then if we go do the same thing with the simulate, then we can see that this simply just prints the y value, it does nothing else. So this is a standard way to sort of set it up. You can go into sort of each of these sub modules and modules to find out what the code is actually doing. But from the top level, from the notebook, you have sort of a clear overview of what is being called and in which order and what results this produces. So this is my recommended way of doing it. Then sort of in the Microsoft structure is about what happens within files. And there's a lot of way you can write a Python program that is sort of correct code, but it's important to also have a style of how you do this, because then it makes it easier to read the code. So there is an official guideline for Python on how to do this. The Python Enhancement Protocol 8 has a lot of guidance on this. And generally it's very, very good to have consistency with this style guide. And if you have deviations, then have the same deviations in a project, and at least sort of within one module or within one function, try to be consistent and have sort of a similar style. So in particular, my recommendation is that you always use the same kind of indentation. I use 4 spaces. Try to keep lines not too long. 79 characters is what you typically say. I always use single quote for strings. It's good to be consistent with that. And I add white space, for example, around an equal sign or around a double equal sign and after colons. And then if I sort of do mathematical calculations, I add sort of a white space around the lowest priority operators in the calculations. At least I do that sometimes. Sometimes I also don't want to do it, but that depends a bit. It can be easier to read in this way. Then you have to name a lot of stuff when you program, and it's not good to do something that's very short, just A, B, C, and so on, because then it's hard to remember what that variable actually does. But it's also not good to be too long, because then it's hard to read. So you want to add for something in between, short but also precise. For modules, I typically use lowercase naming with potential underscore. So that could be numecon or num_econ. While for classes, I use the so-called camel case, where I use an uppercase letter in the beginning of each part of the name that is a word. So consumer, it's a capital, and class is with a capital. And then for variable functions and methods, I again use lowercase with potential underscores. In terms of the actual lines of program, I try to break that into sections, so that each section have a name and a place in the ordering. So the first level is A, B, C. The next level is Roman numerals, and then I simply use O's at the third level. We will see an example of this in a minute. Then it's good to add comments to lines. Again, it's not good if they're too long, then you will not read them if you look through code. So they have to be short and precise. And it should also sort of add some information. It should tell you more than sort of just reading the code tells you. Something more has to be added. And finally, all functions, method, and classes should, in principle, have doc strings, sort of documentation strings. I will tell you what that is below. So one way to think about comments is to say that comments explain to humans what the code does, while on the other way around, the code makes the computer do what the comments say. So that's sort of one way to think about how that should be done. So let's look at an example of what I think is well-formatted code. Here we have a code that sort of have a number of sections. We can see that, okay, it is sort of split into an A section, a B section, and a C section. So this is sort of three different things that's going on. It's probably good to add names here. So I would say that, okay, this is something where I define some parameters. So I could call this section parameters, and it sort of sets these things up. Then this is something that sort of define functions. So I could maybe just call this section functions. And then I have my function, which is sort of, this is not really an explanation of what the function does. So maybe I would like to call this function square, because that's basically what it's doing. We can see that the code line here is squaring the input value. And then sort of this function has what calls a docstring, is that it has these three double quotes here, and then it has some lines that explain what the function does. So this could be it simply squares x. So this is what it does, and it sort of highlights what arguments are coming into this function, an x, an alpha, and a beta, and it's thinking this should be a floating point number, and a floating point number, and it could sort of tell some more about what these variables are thought of as doing. And then they say, well, what does this return? It returns a y value, which again is a floating point number. So then in this way, sort of it explains to you what the function is doing before you actually look at the code. Then the last section here is that it applies our function to the whole list of x. So we can maybe just call it apply actually. And you see now we need of course to change this name here so that it's called square. And I didn't write this right. So now that works. And we can see that now again, sort of now I have another level of naming here with the Roman stuff, where it has sort of applying this function, checking a conditional, and then printing some result here. So we can just check that this code actually runs. It runs. That looks fine. And just notice that one thing that's nice here is that, let's say now the square is actually a rather good name, but you can also hover sort of over it by just placing the mouse over the function, and then it actually gives you the docstring, so you can see what it's doing. It's easy now that the function is just up here, but if the function is inside some module or something similar to that, then it's nice that you sort of actually written the docstring, so you can just hover over it and then you can see what's actually going on. Okay, so I think this is an important recommendation from me, that you try to think about what sections and subsections you need beforehand. You can even write them before you actually write the code. So you can say, okay, what I need to do is I need to set up parameters, I need to set up functions, and I need to apply this. And you know this will be the three sections in your code, and then you can write each section one by one. This gives you an overview. I know that many of you think that this is not that important. You can understand the structure of your code without doing this, and it's often the case you can do it in the moment. But when you go back to the code, and that could be even hours later or days or weeks later, then you cannot remember the structure without having these guidelines here. Or for example, you might not remember, okay, why did I require here that this condition said that y had to be positive? And we can see in the code that it's because we will take the log of it, so it doesn't work if we're not doing that. And here sort of there's a line coming saying non-positive, not allowed due to log. So this is a good line comment that sort of tells you why is this line of code there. Okay, so this was the microstructure of the code. Another term we all can also talk about is how you sort of design your code, the design patterns of the code. And here sort of the three rules that I would like to communicate to you is that there should be no repetition of code lines if you can avoid that. If you have the same line many times, then it's harder to update your program because you need to update each line. It's a good idea to try to simplify tasks into smaller functions and methods such that each function and method does as simple a task as possible. Then it's easier to understand what's going on. And it's important that functions and methods don't have unexpected side effects. So if you call a function and to get some result, it should only give you that result. It shouldn't change something else in your code. I will explain a little bit below what I mean by that. So let's take an example of a profit maximizing firm that has some profits which is an output price times the production function minus what it costs to have the capital, the rental price times capital, and the wage times how much labor it has. And the production function is a standard Cobb-Douglas production function. So now we can write a firm class that does this. It has an init method where it sets up all the parameters and the choices and the prices. So it sets the alpha parameter, it sets the capital and labor choices, and it sets the prices. So you can see here sort of small line comments saying what is each of these variables actually in terms of the economics doing here. And then the function has some methods. It has a method for calculating the production, so that just uses the formula of the production function. It has a method for producing the cost, so how much does the production cost, multiplying the cost of each input factor with the factors. And it has a way to calculate profits, where it sort of calculates the total revenue by multiplying the price with the production, and it has a calculate the cost, and it returns the difference between these two. So that is the profits. And it has both a bad method for doing this and a good method for doing this. So let's just define this function, and let's set up the firm, and let's print both the good and the bad profit calculation here. So we can see that it gives exactly the same values. But what I want you to do now is I want to try to update this code such that there is this productivity parameter in the production function. If you cannot remember what this is called, you can click and see that this is a big theta. So I want you to update with that, and then I want you to think about why are these called profit bad and profit good, even though they give exactly the same result. So try to pause the video here and try to make this update and think about this. I hope you have had some attempt of it, so let us try to do it. So we need, of course, first of all, to add the theta parameter. I will just add it to 1 here. I will just say that this is a TFP thing. Then I will, of course, add it in the production function here. And okay, now I've updated my production function. That looks good, right? So let's call this again so that the class is updated, and let's call this cell again. And now this actually looks good, and this might be good. So let's try to change our theta value to something else, and let's run this again. And now we can see that they give very different results. So what happens here? Why did we suddenly get different results? The problem is that I forgot something. I forgot to update the production function inside the profit bad function. So I need to add the theta in here as well. And then I can run my code, and we can see that now they give the same results again. So why am I calling this profit bad and this profit good? Because when I need to change something in my code, the profit good sort of is correct if I just change the production function. While here in the profit bad, I need to change also a line in there, even though I had actually changed a line previously. And even though actually a lot of this here is just a copy of what's up here. So the problem is with the profit bad is that I'm repeating code lines that could have been avoided. So therefore it's much better to write profit good in this way. So this is an example of what can go wrong if you sort of don't follow this rule of removing repeated lines. Okay, let's continue this example, and let us check whether more capital is a good idea. So here's a function that sort of checks whether is more capital better. It checks whether more capital gives a higher profits. It calculates the pre-profits. And then it increments the how much capital the firm has. Then it calculates the post profits, and it calculates the profit difference here. And then it reports the result. So let's see here, and we can see the report. Yes, this is good. Profits increase with some amount. So I could let's say I call it again. I want to be sure. And it's a yes, but now it's giving me a different amount. and it's giving me a different amount again. Let's see what happens if I just continue calling this. But we can see that it keeps changing the result. And now it actually says no, it's sort of in profits is decreasing. So try to pause the video here and try to understand what's going wrong here. Why is the result changing each time we call the function? I hope you have thought about it for a bit. So the problem here is that we have an unexpected side effect. And what do I mean by that is that I think that this function is only calculating whether more capital is a good idea, but it's actually also changing how much capital I'm saying the firm is, because I'm incrementing this value here. So this is getting updated each time I'm calling it. So what I should actually do is I should sort of update it here. And to some degree, this is also a weirdly placed line, right? So this is pre-profits. Why is there a line about incrementing capital there? I would probably want to move this line down here. And then I would calculate the post-profits, but then I would remember that I should also afterwards reduce the capital again, such that there is no side effect of calling this function. So let's see here. And now, of course, the result will be the result we have with all the changed capital. But now we can see that if we call it again and again, then nothing changes. So this is a better way to have the function. So this is something you need to think about. Is this function giving you unexpected side effects? And it were when we just had this line here, but now it's better when we have this line in here. Okay, the final thing I will tell you in this video is how do you work with these modules in the best possible way. So one thing that might be a bit surprising is that if you call, for example, import my module, then it's only effective the first time it's called. Running import my module again will not reload changes you have made in your code. And that's a bit irritating because you often sort of have the notebook, have some module files, and are updating those module files as you are running the notebook. The solution to this problem is to always call the auto reload magic below in this cell here in the beginning of your notebook, at least before importing. So if I have run this and I import my module, then I can now sort of change my modules, and it will also change the notebook. So let's see this example here, where I try to run my fun in my module with the input of 2. And we can see that this doesn't work. It raises this exception and prints out that A is not defined. So of course now we don't know what the problem is, but we can try to go to my fun and press F12, and we can go into the function. We can already see that sort of it's underlined the A here, so we know that the problem is there. But let's say we didn't see that, then we could press Control-Shift-M. It would open up this prompt here where it would say that A is not defined. We can click here and it would go to that line. Or we could be anywhere in our code, and we could press F8 and it would go to the first error. And here the error is that A is not defined. Okay, so A is not defined, so that's the problem. So let's just add A as a keyword input here. And if we save the file and go back to our notebook and run this again, we can see that now it succeeded running without no problem. So our code has sort of been updated, and we know that when we call it from the notebook. If we hadn't called this auto reload magic, then it wouldn't have worked. So that's an important thing to do. So thank you for today.